to the Short Span Steel Bridge Alliance's 2020 topic-based video series. In this series, we'll review basic concepts and ideas pertinent not only to engineers new to short span steel bridge design, but those looking for a refresher of fundamental concepts. In this video, we'll discuss best practices during construction of short span steel bridges. The goals of this video will be to compare steel versus concrete using a real-world case study and to draw conclusions about preferred best practices. While these conclusions are not comprehensive, they will serve as a very accurate guide for effective construction of short-span steel bridge projects. We'll begin by reviewing the case study in Audrain County, Missouri, and then drawing observations and conclusions as well as thinking long-term about your project. For more details regarding the study discussed in this video, please refer to Short Span Shakeup, a case study on the Short Span Steel Bridge website that can be found at the link shown. The case study in question revolves around the construction of two bridges in 2012 in Audrain County, Missouri. Here you can see images of the bridges after completion. Note that both bridges encompass the same structural depth, the same roadway width, utilize the same railing system, and were constructed by the same work crew. The main difference between the two bridges is that one utilizes a steel superstructure and one utilizes a precast superstructure. Normalizing the cost of the bridge on a per square foot basis, it's easily shown that the total costs of the bridge at the end of the day, as summarized below, indicate that steel was a more economical solution for these two bridges. While this isn't always the case, it definitely shows that steel is a competitive solution in the short span market. Why is this the case? Why was this particular bridge cheaper than its concrete alternative? Well, there are a number of reasons for that, and there are some observations and conclusions that can be drawn that could affect your project. For instance, for this particular project, because both of the bridges encompass the same span and arguably the same geometry, the construction equipment utilized didn't need to be the same. Lighter cranes were required for the steel superstructure. Therefore, since for this particular project the owner owned a 30-ton crane, the owner saved costs by utilizing their own crane as opposed to having to rent one for the concrete alternative. Also, in general, because steel bridges tend to be lighter than their concrete alternatives, the engineer can utilize lighter abutments for the steel solution. There are also some other observations and conclusions that can be drawn for your project that doesn't relate to just this bridge, but short span steel bridges in general. For instance, simple and practical details always tend to lead to efficient designs. For example, instead of a plywood formed traditionally cast concrete deck, the owner for this particular project opted to go with a cast in place concrete deck that was cast atop precast concrete deck panels. Therefore, these concrete deck panels will stay in place. They did not need to be removed after completion of the concrete deck pour. This results in overall economy of the system. Whether you utilize pre-stressed concrete deck panels or metal formwork, stay-in-place forms offer significant advantage over traditional formwork options. Also, instead of using traditional angle cross frames, channel diaphragms were used to serve as lateral bracing for the elements. While potentially heavier than their cross-frame alternatives, these are much simpler to fabricate and much simpler to erect in the field, resulting in overall efficiency and economy in your project. There are also other observations that can be made that can help you as the engineer or the owner think long-term. Other details can serve to eliminate maintenance and costs throughout the life cycle of a given project. For example, the steel bridge in question in Audrain County, Missouri utilized integral abutments. This can serve to eliminate the deck joint at the abutment and can save the owner time and energy regarding maintenance and upkeep of that integral abutment deck joint. Also, utilizing a well-designed durability solution, be it painted steel, galvanized steel, or weathering steel, is definitely going to save the owner time and money down the road. There's a wealth of information on the Short Span Steel Bridge website about durability and coating solutions. Please refer to those pages for more details on durability. This concludes this video on best practices during construction. We hope you found this video informative and look forward to having you join us in the next video. Thank you for your time.